In this lesson, we will learn how to construct confidence intervals for the difference of two population means using the standard normal curve, therefore using the z-interval approach. In this video, we will not do manual computations as much. I will rely on the TI-84 to provide me with the interval. Random and independent samples of 90 recent prime time airings from each of two major networks have been considered. The first network aired a mean of 109.3 commercials during prime time, with a standard deviation of 5.2 commercials. The second network aired mean of 110.7 commercials, with a standard deviation of 5.5 commercials. As the sample sizes are quite large, the population standard deviations can be estimated using the sample standard deviations. Construct a 90% confidence interval for the difference mu sub 1 minus mu sub 2, and this is the difference between the mean number of commercials mu1 aired during prime time by the first network and the mean number of commercials mu sub 2 aired during prime time by the second network. Then complete the table below. Carry your intermediate computations to at least 3 decimal places. Round your answers to at least 2 decimal places. I did not include the table. I'm going to just write out what we will find as our interval. But when you do this assignment on ALEKS, there will be a table for you to provide the lower bound and upper bound of the interval. First, my task will be to identify what I know. I know there was a sample of 90 recent airings from the first network. Sample mean x bar sub 1 is 109.3 and sample standard deviation S sub 1 is 5.2. I also know the second sample had 90 airings as well, and x bar sub 2 was 110.7 and standard deviation for the sample number 2 was 5.5 commercials. Please note that there is an important statement here, and I would like to identify what it is. It says that because samples are large, the population standard deviations can be estimated using the sample standard deviations. What they're saying is that if you know sample standard deviation, let's assume it's the same as the population standard deviation sigma sub 1 here, and S sub 2 will be same as sigma sub 2. Because of a large sample size, this S will be good enough of an estimate for this sigma itself. It really tells me that I know sigma for both populations, therefore I can go ahead and use the Z interval, not T interval in this case. The function on the calculator will be 2 sample Z interval, because I work with 2 samples at once. And when I enter the information I have into my calculator, it will give me the following interval: negative 2.71 to negative 0.09. Therefore, we can be 90% confident that the mean difference between the number of commercials during prime time by the first network and the second network is between negative 2.71 commercials and negative 0.09 commercials. Please note that because we were finding the difference in this order, mu sub 1 minus mu sub 2, and this difference produced negative quantities, it tells me that on average, the first network has less commercials than the second. Now let's take a look at how exactly we use the 2 sample Z interval in action on TI-84. We go to Stat and Tests menu, and our option we're interested in is number 9, 2 sample Z interval. You can simply press 9 or scroll down to it. We're going to enter the information, and first 2 things are standard deviations for populations, which we were told are same as sample standard deviations. So I enter 5.2 and 5.5. Then we're going to enter sample mean for the first sample, 109.3, and sample size 90. Sample mean for the second one, 110.7, and sample size of 90. Identify the right confidence level of 90% and press calculate. Round to 2 decimal places as requested to get negative 2.71 to negative 0.09.